Okay, in the last lecture, we talked about that I was using f of x as continuous. So in this lecture, what we're going to do is we're going to actually define what it means for a function to be continuous. What it means is that the limit has to exist and the function value at that limit has to be equal to what the limit is. So in other words, what that means is that for the limit to exist, it means that the limit as x approaches a from the left of f of x has to equal L, has to equal the limit as x approaches a from the right of f of x has to equal L. That is what it means for the limit to exist. And that limit has to be, the function value has to be L. Another way to think about continuous is that there are no gaps, no jumps, and no breaks. A way to, a non-mathematical way is that you can, if you put your pencil on the graph, you can draw the graph without lifting your pencil. Okay? If a function is said to be discontinuous, if there exist gaps, jumps, or breaks, if the limit does not exist, all right? Or if the function value at the limit is different. Okay, so what we're going to do now is we're going to check this piecewise defined function and see if it is discontinuous. All right, so what that means is that we're going to check x equals 3, and we want to make sure that 6 minus 2x equals x plus 3 at x equals to 3. I'm going to divide my paper in half so that I can work on x equals 6 over here. Okay, so that means that 6 minus 2 times 3, we want it to be equal to 3 plus 3. So that 6 minus 6 has to equal 3 plus 3. So 0 does not equal 6. So we are discontinuous at x equals 3. Now we're going to check at x equals 6. And so right here we're discontinuous. And now we're going to check here to see if we're continuous. We want x plus 3, and we want to see if that equals x squared minus 27 at 6. So does 6 plus 3 equal 6 squared minus 27? So does 9 equal 36 minus 27? And 9 does equal 9. So that is a yes. So we are continuous at x equal to 6. So this function is discontinuous at x equals to 3. So all the points of discontinuity, the only one is 3. All right? So now, for the next example, we want to find a and b so that this function is continuous. All right? So what that means is I am again going to split my paper in half so I can work at x equals to 2 over here and x equals to 6 over here. So at x equals to 2, I want 10 minus a x equal to a plus ax plus 2. So that's 10 minus a times 2 equal to a times 2 plus 2. So that's 10 minus 2a equals to 2a plus 2. So that is 10 equal to 4a plus 2. So that's 8 equal to 4a. So A has to be 2. So now I'm going to use this over here when I need it. I want to show that ax plus 2 has to equal to b squared minus bx squared minus 58. So that is 2 times 6 plus 2 equals b times 6 squared minus 58. So this is 12 plus 2 equals 36b minus 58. So that's 14 equals 36b minus 58. So that gives me 72 equals 36b, so b equals 2. So this will give me the function. My final function should be f of x equals to the function 10 minus 2x if x is less than or equal to 2, 2x minus 2 if x is between 2 and 6, and 2x squared minus 58 if x is greater than or equal to 6. So this now is a continuous function. All right? Now the third way I'm going to talk about continuity is with a graph. Hello. All right, now I'm going to use this graph to talk about continuity. So the first thing I'm going to do is I want to make sure that you realize that this graph is hugging up against that curve, because that didn't come through very well. At f equal to -2, the value of f of -2 does not exist, because at -2 it's going to negative infinity and positive infinity, and because going to plus or minus infinity and no closed circle. All right? Now, if I look at the graph from at the limit as x goes to -2, I want to look at the limit as x goes to -2 from the left of f of x. This goes to negative infinity. If I look at the limit as x goes to -2 from the right of f of x, this goes to positive infinity. So therefore, this limit does not exist. Okay? So now I'm going to scroll down just a little bit so I can get to the next one. All right? If I look at 0, my closed circle is at 2, so therefore my answer is my f value is at 2, and that's because the closed circle all right, the limit at 0, so the limit as x goes to 0 from the left of f of x. So from the left, I'm coming down here and I'm going to -1/2, and the limit as x goes to the right to 0 of f of x, this is going up to +2. So since -1/2 does not equal 2, this limit does not exist. All right? The value of 2, now notice that this right here is an open circle. So I'm going to undo that because I'm going to need that space in a minute. This value right here is an open circle, so this value is does not exist because it's an open circle. This is an open circle, so the value of this function is does not exist. If I look at the limit as x goes to 2 from the left of f of x, so this limit as x goes to 2 from the left of f of x, it goes down to a half. And if I look at the limit as x goes to 2 from the right of f of x, this goes to a half. And so I'm going down to a half. Even though the function value at 2 is an open circle and does not exist, this limit value is a half. All right? Just because the function value does not exist does not mean that the limit does not exist. It means the function is not continuous, but it means that the limit exists. All right? I want you to make sure that you get that. Okay, now let's look at number 4. All right, now I'm going to go up here and I'm going to get the information from the graph. So at 4, I have a closed circle at 2. Okay, so my function value of 4, this function value equals 2 because of a closed circle. All right. Now I'm going to scroll back up here and get the limit information, then come back down here and write it down. All right, so notice as I go from the left, I'm going up to positive infinity. And from the right, I'm going up to positive infinity. All right, so I'm going to go back down here. I'm going to write these down, and then I'm going to explain them and write them down here. So the limit as x goes to 4 from the left of f of x, this goes to positive infinity. And the limit as x goes to 4 from the right of f of x, this goes to positive infinity. Even though these go to the same thing, that answer is positive infinity, which means that the limit does not exist. All right? So I want you to make sure that you